My pleasure to introduce John. As you heard from him this morning, he is the VP for on-orbit servicing with Voyager Space Holdings, and he will be the moderator today. And again, if there's any questions, if not seeing the screens or somebody lets me know, but for the rest of the time, I'm going to be on mute. So John, I'll turn it over to you.
Okay, thank you. So want to preface this panel, we're going to be talking about satellite servicing interfaces. As you've seen over the past 2 days, most of the servicing missions to date have been using unprepared legacy client spacecraft. However, as many of us on this panel and throughout the industry have been advocating by preparing spacecraft with features to enable servicing, you can open up a lot more advanced servicing and assembly capabilities. So on this panel, we want to highlight some of the work that's going on at several CONFERS member organizations on developing satellite servicing interfaces, discuss some of the issues facing the development and standardization of interface technologies, and discuss potential next steps to facilitate widespread adoption of these interfaces. So today we have 5 panelists who will be joining us. We have Rob Hoyt with Tethers Unlimited, Pierre Letier with Space Applications Services. We also have Talbot Yeager with NovaWorks, Jörg Kriesel with IBOS, and Patrick Lerner with Altius Space Machines. So the way we'll do this panel, each of the panelists have prepared some remarks if you are pre-recorded, if you will be live. And so I will briefly introduce each of the panelists. We'll either play their remarks or have them give their presentation. And then after that is over, we will jump into a discussion and Q&A period. Apparently, because of the concurrent nature of these panels, they don't have a Q&A button like they did for the main discussion panels previously. So in order to submit questions, there's the chat function down at the bottom. So submit questions via chat, and I'll try to monitor those when we get into the Q&A period and work in audience questions. So with that in mind, why don't we jump in? The first of our panelists is Rob Hoyt. He is the president and co-founder of Tethers Unlimited, an ARCA subsidiary. Rob started TUI in 1994 and built it into a multi-million-dollar space technology firm that provides high performance small sat components, in-space manufacturing capabilities, and robotics assembling capabilities. So with that, let's start with Robert's presentation. I think he had a pre-recorded one.
Okay, hi, thanks, Jonathan. So at Tethers Unlimited, we've been working for over a dozen years developing capabilities for in-space manufacturing, in-space assembly, and in-space servicing. Many of you hopefully know that we've been working on a compact, low-cost robotic arm called the Kraken. And we're currently getting underway on a new effort funded by DIU to integrate the Kraken arm with connectors and control software and vision into a integrated robotics payload for small satellites and persistent platforms. And a key part of that will be demonstrating a servicing interface that will allow a modular payload to be integrated, captured, and integrated onto a host spacecraft. So under a handful of different NASA and DoD SBIRs in the past, we've developed a suite of connector technology that we call the Axon Smart Connectors, and there are 3 versions of them that are shown here. On the left is the Axon tool change interface. This is primarily a hot swap tool changer for our Kraken robotic arm, so that the arm can have a handful of different end effectors and easily swap between them. But the tool change interface is designed as an androgynous connector, so both sides of the connection are the same. And what that means is we can also use that as a docking point and a mounting point for both for other, for free flyers, other equipment. And it can also be used to support inchworming operations of the arm, so the arm can be mobile around on a platform. The Axon servicing interface builds upon the tool changer interface and integrates a electromagnetic soft capture solution to facilitate capture and docking with a client spacecraft. That client spacecraft does have to have a compatible servicing interface mounted onto it, which is illustrated there. So the electromagnetic soft capture provides a little bit of electromagnetic force, which combined with the active compliance of the Kraken robotic arm facilitates initial capture of a client object and provides a little bit of reaction force against which the tool rapidly and securely makes a hard dock to the client interface. And then that servicing interface can integrate optical, electrical, and/or wireless connectors to provide power, data, and other services. And then to enable in-space assembly of modular space platforms, we've developed a larger version of the connector that we call the Axon payload connector. Shown there, the prototype is about the size of a can of Folgers coffee. This connector is also an androgynous connector, so both sides are the same. And one of the important aspects of it is that either side of the connection can secure or release the connection, which is important for being able to swap out a dead module or swap in a new module. It also integrates a irising cover to protect sensitive connections and optics when it's not mated to a matching connector. This one is designed for being able to transmit higher power levels and can integrate a variety of different electrical and/or wireless or optical connectors. So that's a quick overview of some of the connectors we've been working on, and we hopefully will be demonstrating one or more of these on orbit in about 3 years from now under the Gauntlet program. Thanks very much.
Thank you, Robert. Okay, so our next panelist is Pierre Letier. Am I pronouncing that right, Pierre? Okay.
It's very nice, yes.
Okay. He is the team leader for robotics mechanisms and structures at Space Application Services, a Belgium-based space technologies company. And I'll hand things over to Pierre.
Thank you very much. So I will make here a very short introduction about our company, and more specifically our activities around standard interfaces, connectors, and on-orbit servicing applications. So can go to the next slide, please. Can you go to the next slide? Is it? Okay, thank you. So as mentioned, Space Application is a Belgian company located just beside Brussels. And we have more than 30 years of experience in the development of space systems and applications. The next slide is showing you a mosaic of our different field of expertise. As mentioned in the name of the company, we have mainly two scopes of activities. Behind the term application, we cover the development of space systems and devices from early prototype to a space qualified version in different fields like human spaceflight, space robotic exploration, or control systems. And on the other side, behind the term services, we provide to external entities, companies, and space agencies consultancy and support in engineering and space science. So now I will go more quickly to the our activities related to the development of standard interfaces. So this is showing our recent achievement with the development of the hotdog standard mating connector. So as most of other devices, it shares some interesting features like androgeneity, but also some specific aspects with like, for instance, high load capabilities, high mechanical load capabilities, and provides in a very compact shape the 4 kind of typical interface that are very promising and interesting for future on-orbit application, including mechanical, data, electrical power, and also thermal or fluid transfer. So this has been developed in order to answer the future challenges of operation in space through different initiatives in the last years, mainly related to the European Commission projects and ESA projects. As you can see on the bottom right, for instance, in relation to the talk that was just provided by Gerhard Grunwald just before this session, in the Pulsar project, it has been used to demonstrate the assembly of a large structure in space through the multiple connection of telescope tiles and the operation of data and power transfer to operate the active elements on the tiles. You can go to the next slide. That is showing and illustrating the recent result of a project called Mozart, for which I was the coordinator, where we have a lot used also these standard mating connectors. So the project Mozart is about the operation and development for modular, of concept of modular and reconfigurable spacecraft. So this video is showing the hardware and demonstration site of the project, where the target was to demonstrate a concept of operation from a servicer spacecraft, bringing some modules, spacecraft modules, to assemble and reconfigure a client satellite. So this is typically just what you see currently on the video, and this is performed by what we have called a walking manipulator. So this manipulator is equipped on both sides with hotdog interconnectors, and that enables, of course, to connect and manipulate the modules, to also power them and make communication with them. To perform the operations of reconnections, for instance, like at this moment in the video. But it is also used to allow the walking manipulator to relocate itself along the structure or on top or the side of the modules. So in this project, we have also performed other kind of applications related to the development of the data network and the power network, but maybe that is of course not on the side of this session. So related to this development, so that has been finalized and demonstrated in the beginning of the summer, and now we are following up these activities with other follow-up projects in the European Commission with the Period and Eros Plus project, where the hotdog interface will be also used, compared. There's some benchmarking done between different devices in the context of the definition of an IOD demonstration mission that is foreseen in the coming years. And also we have we are working also currently on the ESA project called Mirror, where both the standard interfaces, hotdog and the walking manipulator, will be re-implemented in an application related to the assembly of a large space structure. Unfortunately, the video is a little slow, so I will just maybe making my conclusion now, waiting, because the next step is that you will be able to see the walking capability of the manipulator. So I encourage you to also visit our website or our YouTube channel, where you will be able to see other videos and the full version of the video. Sorry, because I have a question rising on top of me, so I don't see. So you will be able to see the different videos and operations in a better way. Voilà, so I think you have seen now this working capability. You can maybe go to the next slide. So here are the links for the company and the YouTube channel, and also the link to the different projects where these devices have been developed and integrated. Voilà. Thank you.
Okay, thank you very much, Pierre. So, excellent. So next up, okay, it looks like next up we have Jorg Crystal with IBOS. Is that the next one? Or is it NovaWorks? Oh, okay, sorry. Next up we have Talbot Yeager with, he's a co-founder and CTO of NovaWorks, a company pioneering the development of cellularized satellite technology. I'm getting some crosstalk here. Is somebody else not muted? Okay, thank you. Yeah, so next up is Talbot Yeager. He's the founder and CTO of NovaWorks, a company pioneering the development of cellularized satellite technology. Talbot has led the invention and development of NovaWorks' patented integrated satellite or HiSat technology. And I'll let Talbot go from here.
Hello. Yes, I'm Talbot Yeager, CTO of NovaWorks, and I'd like to share a video with you. Gives you a quick overview of what NovaWorks is doing. Run that video. There you go. We're advancing what's we call really the space Lego platform system. That system enables and provides a better way of doing space, so that the space superhighway and the space commerce system is enabled and it's protected and it's ready for the future that we're all bringing to space. You can see in these videos the examples in the last few years. We've had bad actors in space, we've had debris, we've had hits on ISS, and space is a contested environment in addition to being innovative. So what we bring is building blocks, as you see, these assembly interfaces, supporting contracts. And we're trying to take this, as we've been developing in stealth for many years, on our air tables, developing on aircraft. We've used robotic testing. We've worked with actual spacecraft builds. These space Lego building blocks and interfaces have been used in space for testing and space assembly. And really, it's a variety of very active involvement in creating environmentally sound, radiation strong, strength testing, compliance testing on a variety of test beds. So this technology has really been proven while we've been in stealth. 2 years ago, right before the pandemic, actually, we came out of the stealth mode to work and start to show really how we can give ourselves new options in space. The building blocks and the interfaces have built-in space domain awareness. They can understand their environment and debris. As Dr. Densing relayed this morning, they also have space traffic management involvement. There's an auto RPOD capability. Deorbit is built in, and robotic handling. What that does, if you put enough features into a system and a platform, we get new options in space. We get platforms that can basically disaggregate and move around freely. They're refuelable, they're renewable, they provide a next generation capability to not only have the features of modern spacecraft, but also a future spacecraft. We're really trying to future-proof the ability to fuel and work with this vision of going beyond LEO, GEO to cislunar. These platforms can be workable on the lunar surface, at Mars, on the Mars surface. They've really been next generation design. So that's where we've been coming with these new capabilities. And the demonstrations were to take this basic interface. We have five interfaces on a building block that's no bigger than a 4U. we've taken this interface and energized platforms, payloads, new components. And this is also that we can not only address new threats, but also provide new capabilities. So that's what NovaWorks is doing. The purpose is, as you can see, as we get some of our space domain awareness photos from our testing in orbit, we want to thrive in space. We want to make space so that the entire issue of OSAM and beyond is ready to go into all sorts of areas for innovation and next generation proofing. So thank you for that. And we really look forward to working. We've run a cohort for OSAM, and we're working together with those companies and working really the future with everyone for space. Thanks.
Excellent. Thank you very much, Talbot. Okay, so next up we have Jörg Kriesel with IBOS. So he is the chairman and co-founder of IBOS. His background includes supporting the creation in early years of RapidEye, working as a venture capitalist, serving on the boards of several high-tech startups. And in 2017, Jörg founded IBOS in Germany to enable modular plug-and-play future of space infrastructure and logistics. Okay, I will hand things over to you.
Yeah, well, hello everybody. Thanks for having us here. So yeah, it's my pleasure. Also on the also here amongst the participants is our CEO Thomas. Yeah, I want to share a couple of things with you about our prime, which is the ISSI, the Intelligent Space System Interface. That's what ISSI stands for. It is a fully modular coupling kit, yeah, supporting a lot of things around on-orbit servicing, OSAM, and so forth. Next slide, please. So first of all, let me just share with you kind of our vision, mission, and what we are up to. So our company is out there to provide standards for people who want to do, or you guys want to do on-orbit servicing on OSAM to enable your business by providing this ISSI multifunctional interface with a lot of flexibility, features, and so forth. So our mission or idea is to provide that USB for space to let the OS community to do sort of Lego in space. So in essence, what we are trying to support is ultimate plug and play of space systems, both in orbit and in exploration missions. So that is basically our mission, and our company is solely around this sort of topic with the interface and associated building blocks. And let me show you what our interface is all about. We will not show a video, but we can provide all these kind of things later. We just want to focus on a couple of key messages here. Next slide, please. So here is the ISSI, and what you see is the 3-in-1 baseline. So the ISSI, Intelligent Space System Interface, on the left side is hardware, on the right side you see a CAD explaining some of the functionalities. Is a device which is currently at TRL-6, and we are flying it in space later part this year in the course of a US mission. You will see that later. And so we have hardware. We built more than 120 of those, which have been shipped around the world in test and laboratory type of applications. In principle, what you see here, there's an interface which is totally modular. You see this later. And in the center, there is a kind of one of the two data interfaces. We have two data interfaces, a high-speed Ethernet for the time being, but we also have other protocols, optical interface, and a CAN bus optical interface. We have a mechanical connection. We have a power connection. And we can transfer power of 5 kilowatts. We can go very high in data transfer. Currently in the lowest configuration 1 gigabit, with the same technology up to 10 gigabit, and we're currently working on a terabit connectivity of a modular exchangeable data transfer interface. So next slide, please. Here you see the same thing. So our USB in space, Lego in space, yeah, is again the same picture, but on the right hand side we have kind of summarized a couple of key features here. There's a couple of other solutions, very good solutions out there. We've just seen some of them which provide multifunctionality as we do, mechanical, power, data, and thermal. Our interface is not a monolithic interface. It's totally modular. Each functionality can be changed and replaced and upgraded and changed by protocol or changed by specs, etc. It is scalable in size and per functionality. It's androgynous design, so no male-female. It is very fast coupling and with an adjustable coupling speed. It has a fail-safe functionality, etc., etc. But unparalleled is probably that it has a flat surface. It has multiple mounting options. You can mount it from the sides, from the bottom, and from other places. It's very compact. It's patented internationally and is currently at TLL6. Yeah, let's go for the next slide, please. Here you get an idea on the hardware. On the right-hand side, you see the power pins coming out, which also support the mating by kind of helping to adjust the two interfaces together. And those power pins will then transfer the power. On the left-hand side, again, the key functions is of the ISSI is multifunctionality, mechanical power, data, thermal. Fully modular, compact, very light, it's scalable, and it's very fast with in terms of coupling speeds. Actually, we can couple below 5 seconds, but usually 10 seconds, and you can steer the coupling speed. Next slide, please. Yeah, and that is basically our prime message. So the prime message here is that the interface is fully modular. So we offer it as on the upper left box as an active interface with gear and motor, as a passive interface, which is then only 150 grams and below 1 centimeters in height, same diameter, and then on the bottom left in the box you see add-on modules to cater for different applications. In the middle you see a thermal interface which you put on the interface like a hat. On the left hand side is a form fit which can be adjusted and customized depending the various applications to increase diagonal engagement or misalignment tolerances and higher loads. On the right hand side you see a dust cover for planetary applications and the associated hardware, not the CAD drawings you see on the right. That is what it looks like in hardware. On the upper right box you see also that even the motor and alignment pins and the data interface, all these elements are modular. You can just take on and off. You can move from Ethernet to other protocols and space wire and what you name it. And depending on what it is, and even the data rates can be changed, and the motor can be changed from Earth motor to a space motor when you put it in space and so forth. Next slide, please. Yeah, here's a bit of an outlook and a couple of other applications. You see a couple of pictures. In the background is this interface in lab testing. On the upper right is a more recent application. So we have a project going on with several partners to develop kind of joints and modular robot arms, which use this interface for prolongation of different arms lengths and these types of things. So our interface is also meant to be a robotic end effector, a robotic joint, a robotic arm module interface. A robot foot for walking robots. We have a couple of projects going on with different partners. On the left, you see the Archesis, the port project for which the ISSI is baselined. On the lower left and in the middle, you see a couple of lab applications already in 2015. That was end-to-end demonstrated in lab environment. In 2016, there was kind of real case kind of examples. And then you see our mission patch. We have an orbit demonstration mission coming up with DIU, NASA, and the ISS National Lab. Later part this year about the ISS on the Japanese Kibo module. That's it. So yeah, that's a bit of an outlook here. So in essence, we are trying to support any type of robotic type of things without being in the position to offer the services themselves, but all the way from cooperative design support, connection of modules, payload adapter, servicing interface, and so forth. That is what this interface is all about. Here's the mission patch, the outlook for the future. And yeah, last slide. Yeah, here is just an outlook on what it is. So the IBOS ISSI interface originates from the IBOS project. Here's sort of the vision of the IBOS project. And so the question is, where's the standard? The standard is, in our view, yet to come, as we see changing requirements for different applications, and we want to cater for flexibility and making sure that we can adjust as we move forward. We have a couple of applications where, on the basis of the same interface elements, different needs can be served. So that is the end of our little tell, and you find this presentation when you go to the CONFERS website on the members and click on our logo. You come to this presentation. Thank you.
Okay, thank you very much, Jörg. Okay, so last up we have Patrick Lohner. He's the new CEO at Altius Space Machines, actually replacing me there. Prior to joining Altius, Patrick's background includes several business development and technical roles throughout the satellite space economy, including working at Seekers Engineering, Space Systems, Thorold, DirecTV, and Hughes Space and Communications. So with that, I'll hand it over to Patrick to introduce us to what Altius is up to.
Thanks, John. Good morning, everyone. Happy to be here today. And the topic of interfaces is certainly near and dear to our hearts at Altius. I think we really have a goal of, I think we see that there's a tipping point in the industry as we have more of these interfaces on orbit. I think it's sort of the rising tide raises all boats. And so that's sort of a focus for us at Altius, is to get more of the on-orbit platforms, call it OSAM ready to some degree. And I think interfaces are a key part of that. So next slide, please. So this is our dog tag grapple fixture. We have hundreds of those on orbit on the OneWeb constellation. It was a pretty rapid development. I think it was a matter of 8 months or so from the initial contract to delivery of flight hardware. And as you can see, there's multiple capture methods that the dog tag supports: mechanical, magnetic, gecko, electrostatic, magnetic, so forth. So it's really intended to be a multifunctional approach that will work with multiple capture techniques. Fully space qualified with the Airbus OneWeb folks. So for us, it was exciting to work with them. And I think there was a learning curve for us in terms of what their needs are, integrating interfaces into their platform. And so that's knowledge that we've continued to leverage. And going to the next slide. So this is sort of a progression from the dog tag to what we call the mag tag. It's a multifunctional configurable interface. You see a little bit of the stack up there on the left. The core concept is to have sort of a common element that's based on our EPM modules, or electropermanent magnet modules. You can see those in the lower center of the slide here. And the outer ring can be adapted to add more or less of the EPM modules, and then the functionality and the configurability that we see is really with the center core. So this design supports power data interface, fluid transfer, and as you see at the bottom right of the slide, we're actively sort of surveying the industry to see what other needs there are and to understand those. But our approach has been to really have something that's dynamic, that's adaptable, reconfigurable, and in terms of the species of fluid transfer, power and data transfer, the levels of those that are supported, and the holding force that's provided. There's a lot of flexibility in this interface. We've got a number of development programs that are going on. The EPM technology we see that as a fundamental building block that we want to leverage in our interfaces going forward. So there's been a lot of progression there in that technology at Altius that we're excited about. But again, I think the ability to have, and I think a lot of our panelists have touched on it, sort of a modular approach, interfaces that enable different functionalities, I think is going to be key for our industry going forward. And so that's sort of an overview of our interface work at Altius, and we're very excited to kind of continue to evolve this and work with the other folks in this industry to get that done. So thanks for your time today.
Okay, excellent. Thank you, Patrick. Cool. So we now have, looks like about 25 minutes for the discussion period for this panel. You know, looks like we've had a few questions that were asked in chat and already answered, but if you have additional questions, feel free to add them via the chat function, and we'll work them into this discussion. So, you know, I had kind of two, you know, pre-thought out questions of my own, and then, you know, we can work in audience questions, and then also panelists, if you have questions for other panelists, you know, I'd also be happy to entertain those as well. So first question I wanted to ask you guys. So right now, there's been a lot of interest in CONFERS as an organization trying to push towards interface standards. You know, there's a lot of people out there that, you know, especially in the government side, that they're like, okay, there's a lot of options out here. You know, what should I be putting on my spacecraft? How should I be designing my spacecraft to be, you know, compatible for future servicing? You know, but we've also noticed, you know, several challenges to, you know, driving to actual, you know, agreed upon standards. I mean, the two main ones that I've seen are, you know, as you've seen here on this panel, there's a lot of great companies that are working on different interface standards out here. And a related idea is that, you know, that several people have brought up in meetings before, is that you don't necessarily want to lock in standards prematurely, you know, before they've been both tested, you know, not just flight tested, you know, but also tested by the market. And so the question I'd like to pose to each of you is, you know, what can CONFERS do as an organization to help try to solve those challenges, you know, and accelerate, you know, the pace at which we can get to standards that people, you know, can use in space that are agreed upon, you know, by industry. So, you know, if any of you would like to jump in on that, you know, let me know.
I can start on that, John.
Go ahead, Talbot.
Yeah, I think you hit it already, actually. The market is going to be a large determiner between our commercial customers and government customers. The real market that develops needs to make this decision, I think. I don't think you can force it. And so what is the answer then? The answer is to grow the market, to find methods that allow this group and others to, you know, put their services forward and put their capabilities in orbit and provide a proving ground for all this. The more we focus on teaming together to do that, the more the market develops, the more we'll find a standard. But I find it hard to find the king of the world that will dictate which standard is the right one. So I think you're right. I think you hit it. The market needs to be it. What we can do, in my opinion, to help that is to build the market.
All right, cool. Thanks, Talbot. Rob, Pierre, Patrick, Jorg, any other thoughts you want to add to that?
Yeah, I would agree that I don't think it's the right time for CONFERS or the government to legislate a particular interface solution. Where I think CONFERS can help is to define standards for, you know, requirements, especially regarding safety, you know, reliability, those sorts of things for the various providers to follow, so that we're, you know, we're all being good stewards of the space environment. But yeah, I agree that, you know, there'll be 5-10 years of chaos as the various offerers are scrambling for sales, and probably one or two will kind of come out of them as the preferred choice, but I think there should always be room for further innovation.
I think also that the aspect about the technical requirements of the interfaces, basically from the different projects where we were implicated recently, it's always coming with different requirements, because you have always something more that has to be added to the interface or something less. And I think that there is a lot of different applications in this field, different sizes, different needs of transfer, different needs of operations. And I guess for sure there will be different standards related to standard interface and connectors. But also I think we need time to converge, and that's first converge and also validate and test different approaches, different technologies, and of course on orbit. But mostly currently there's still too much different requirements and different options that are on the table that to be able to in the coming years, I would say, really be able to focus to one technology.
Yep. Yeah, well, and I guess it's kind of fair to mention is like USB ports are kind of used as the standard analogy for what we're trying to do, especially on the power data transfer side. But even within the electronics world, there's still a range of different interfaces, and even with decades of working on trying to converge, it's like there's still more than one interface. It's not one interface that solves every single problem ever invented. So I definitely agree that even once you get some convergence, that there will probably still be a mix of solutions out there. Good point. Let's see. So Jörg, Patrick, did you have anything you wanted to add on that one?
Well, yes.
Go ahead, Jörg.
Well, yeah, anyway, so I think I agree with what has been said. I think where CONFERS could really help is that it is not yet fully understood to all the various stakeholders in the space industry what an interface is all about. There's a lot of confusion, and so it's not just a connector. And that's one thing. The other thing is we try to make it sort of as if other people could do the same thing, say that we have this USB for space. But I think we have got to distinguish between, on one hand side, the functionalities, potential functionalities of interfaces and the applications of interfaces, what they can do. And if you connect something physically, mechanically, that's one thing. So I think CONFERS could help kind of educate the community, both for functionalities, as far as functionalities of interfaces are concerned, as well as applications. One thing. The other thing is sort of setting a framework which basically goes along the lines of safety, along the lines of self-inspection, these types of things, which do not yet boil down to specific specs, technical specs, because as it was just mentioned by our co-panelists here, we are dealing with a couple of things which are yet in a flow, or we are dealing with moving targets. So that's too early to do. A very important thing is what we keep hearing all the time is, what is the interface of the interface? So, we're talking about the interface, and people come and say, hey, yeah, but where do we put it? What is the interface of the interface, right? So is it going to be in a panel? Do you mount it on something? It's going to be on a boom, So that is an answer which we have to come up with. So I think CONFERS can set a framework in the way, what are the boundary conditions, the recommendations, safety, self-inspection, whatever it's going to be, and then explaining applications and functionalities, as well as educating the community.
Thanks, Jörg. Patrick, do you want to add anything?
Yeah, I agree wholeheartedly with what Jörg just said. I think from my perspective, I'm coming more from the folks that the satellite operators, satellite communications side, the folks that are not nearly as familiar with the work that's going on. And so that's where I really agree with sort of the communications aspect, the clarification aspect that CONFERS can provide. And as was said, defining sort of a feature set of what these interfaces can offer, grappling, fluid transfer, data transfer. I kind of frame it in almost in terms of making it easy to buy. If you go on a website and you're trying to buy an iMac, you have to make about 5 decisions and you're done. Other computers, you go through and you can spend an hour and a half trying to figure out what they offer, what it is. And I think the more we can gravitate to a model where there's a feature set that operators know is available and they can start to select from and drill down, I think that aspect of it, and I agree that it's premature to really define perhaps detailed specs, but to maybe gravitate to sort of a form, fit, function definition of that feature set, such that operators and government agencies like SDA can get their minds around what's available. I think that will be a key for us going forward at this stage.
Mhm. Yeah, I like the idea of, trying to educate, government and commercial customers about what's the art of the possible. Like, what can even having these sorts of interfaces, what sort of applications, and, like the more, one thing I've noticed is like so many people that we talk with in industry about satellite servicing seem to only think of it in terms of life extension, extending the life of an unmodified spacecraft and just continuing to do exactly what you've done before, like trying to help, trying to help educate them on the breadth of different creative things that you can do once you have a properly prepared spacecraft, I think could help a lot. And, also getting them to push out requirements and say, oh, cool, well, could you do this or that? And, as you start getting that more data, it should help with, figuring out what people care about and going from there. Okay, cool. So that was a good discussion. Next, I've got one other question I wanted to ask, but before I jump in on that one, I wanted to open it up to panelists. Did any of you have questions you wanted to ask other panelists? Okay. I take that as a no for now, but oh, Talbot, did you have something?
Just actually not a question for the panelists, but as Neil pointed out in the chat, something that we may not have addressed is CONFERS is a good location to keep specs. As Patrick talked about and others, where the different features of the developing and emerging interfaces can be recorded and shared with the members and shared with the community, so that as a group we can collectively help disseminate that information. George is right. We need to communicate better. Maybe that's a great feature of CONFERS. So I thought Neil's comment in the chat was good there.
Okay, awesome. No, that's a very good point too. Okay, so my other question, and this one I haven't run by you guys in advance, so sorry if it's a bit of a curveball, but I've noticed, especially as engineers, we tend to get religiously attached to our own technical solutions. And there's actually a kind of interesting concept, that a Swedish theologian brought up of holy envy. He said of this concept of leaving room for things that you admire in other approaches that you wish you could incorporate in your own. So I know this is a bit of a curveball, but my thought is I'd love to get from each of you. We've on this panel we've had 5 different companies, but there's probably at least a dozen companies in CONFERS that have been working on interfaces. You've all seen each other's stuff before, and you've seen other stuff. And what I'd like you guys to do is think about things that you've seen in other people's interfaces that you think are cool, interesting, admirable, clever, elegant, whatever. And just share like one thing that you liked about somebody else's interface, whether on this panel or whether somebody else at CONFERS. So since I haven't been getting a lot of questions, I'll do this uncomfortable question for everybody, but hopefully it's a fun exercise. So not to put people on the spot, but I'm just going to go back through the order that we had with the panelists. So Rob, do you have anything that you've seen in any of the other panelists or any other CONFERS group interface wise that you found is really neat or cool or admirable or interesting?
Well, I was really impressed with the space applications connector. I'm jealous they've obviously had good funding from EU to mature that along. And that was an impressive demonstration.
Cool. Thanks, Rob. Let's see who is up next. Pierre. Oh, you're muted still.
Yeah, I was very interested with the first presentation because we knew about the first column, I will say, but what's very interesting is to see how the typical technology and an interface can be rethinked, maybe not keeping a same design or same purpose, but really changing a little the concept and the technology of the device to address really other specific needs, the soft aspect or larger payloads with other type of operation of the interface. And I think it's quite interesting also to be able to explore and expand the field based on a first principle. And that is a very interesting approach, I think.
Cool. Thank you, Pierre. Let's see, next up, Talbot. You're muted still.
I'm always enamored with everyone's interface. We've done so much testing. There's testing on aircraft, air tables, with robots, in free space, in actual space. Whether you have a robot to guide you, whether you have to do an RPOD, that level of testing and seeing where everyone is going. I know the learning curve for us is very difficult. It's not easy. You refine, you adjust, and you make all these things work. So I'm impressed to see everyone's designs and how they progress, because I know how difficult this area of innovation is. So whenever we get together, I'm just impressed with the whole team, because the amount of effort it takes to make a good dock, to make a good assembly system, to make a good awareness system, it's not trivial, and no one really appreciates that until you get into it. So people on this panel, I commend entirely there. This is quite a journey we're on.
Okay, thank you, Talbot. Jorg.
Well, yeah, I have to admit, of course we are aware of the other groups and other interface solutions, and I think they all have merit. Personally, I think there's probably we will see solutions. For instance, as we see in the project we're working on with Archesis, the port, where several interfaces have been baselined. So I see really a coexistence of interfaces around certain modules. If you have this big element which has to fulfill certain functionalities, I think there is space for several of them. So we know hot dog from the start, and it's pretty cool and interesting development. The Axon solution is of course impressive, particularly with regards to the lightweight structures and others have looked into other things. So we have gone through the Industry 4.0 mass manufacturing process, which is the next challenge, because after having it demonstrated or the prototypes, it's about how to manufacture these things. So I think each of us has learned a lot of things, and there's most probably a coexistence of certain interfaces, while standards are yet to be defined. And I agree with some of the comments we have seen here in the chat, so that, of course, where are the specs, and it will help to have this kind of easy to buy kind of thing, as it was proposed just before in the discussion by Patrick. So I think that will make a lot of sense. Another thing is that what is the next thing to this? On orbit servicing, so we are building interfaces, but there will be modules and building blocks, right, and other elements to this. So I think that is the big question. If you have a module which then has to do certain things, it may have 2 or 3 different interfaces to go for these and that mission. So we don't know yet. And we are around in this industry on orbit servicing kind of thing for a long time, and still We don't know exactly where we're heading, but it's about converging now.
Excellent. Thank you, Jörg. And then Patrick.
Yeah, one of the things that came up for me as I was listening was a couple of my co-panelists, and I'll echo the impressiveness with my co-panelists as well that other folks had talked about. You know, it's a joy for me, especially being relatively new to Altius, to be involved in this and to see the great work that other folks are doing. But one of the things that came up for me, a couple of my co-panelists mentioned androgynous connectors. And I had been sort of mentally framing it as a, you know, in the context of, say, a Leo constellation or something like that, a lower cost half of the interface and then a more complex interface that carries most of the blocking and tackling on the servicer side, for instance. And so I didn't necessarily want to confuse androgynous with identical on either side of the interface, but was curious what other folks thought about a construct of, and whether you call it low cost, high cost, or active, passive, I'm not sure. I guess it depends on the feature set. But is there a sense of trying to have a more widely distributed side of the interface that is less complex, lower mass, lower cost, and then the other side of the interface, perhaps that would live on the servicer, that is the more complex side of the interface, and kind of managing it in that way? Curious to hear what people think about that.
I'll jump in there. Yeah, I definitely agree with that. You know, our efforts have focused on coming up with mostly androgynous designs, but there, you know, even for that, there's definitely use cases for having a lighter weight, lower cost passive side. You know, but we still want to have, you know, two active systems to be able to mate, just to provide the widest range of functionality and you know, the right price point.
So I think that there are several companies, also the one from Hotdog and also ours, which is endogenous in design, but also offers, let's say, an additional passive interface, which is reduced in mass, reduced in capabilities, or in mechanical coupling capabilities. And this also makes a lot of sense regarding saving costs and also for the flexibility of the system. In the end, I still think that androgynous approach, even with two active or one active, one passive, is providing for certain applications a lot of benefits.
Excellent. So I noticed we're down to the last 2 minutes here before the panel wraps up. And, you know, just wanted to, you know, thank all the panelists, you know, for participating. You know, it's exciting to see, ATI just shared the link in the chat for the main session that we'll be jumping back to. But it's been cool to see the, you know, technical approaches and the progress everybody's making, you know, the opportunities coming up for flight demonstrations. And it'll be interesting to see, you know, as we go forward, both, you know, the competition and also the collaboration. You know, I liked what Pam Melroy was saying yesterday about the idea of collaborating to compete. So anyway, with that, just wanted to thank everybody for their participation, for the good questions and thoughtful responses. And with that, why don't we wrap this one up and we can rejoin the main session. So.